All right. So let's take a look at this problem. Latanya and George are saving up money because they both want to buy new bicycles. Latanya opened a savings account with $50. She got a job and is determined to save an additional $30 a week. George started with a savings account of $75 and he was able to save only $25 a week. Use at least two different ways to find the time in weeks when Latanya and George will have the same amount of money in their savings account. You can use the grid, but that's not the only way. Was anyone able to find when these two had the same amount of money in their savings account and be willing to explain to us how you got that answer? Nobody got it? It's okay. Yeah.
After 5 weeks,
Okay. How did you find that?
by marking every week on the chart with a with the line graph.
Okay, so you graphed a line.
Yeah.
Okay, so I'm gonna have to make this smaller, and I'm probably going to go blind trying to look at it because it is really, really small. But so, how did you draw your lines?
So I started with um, the first person at 50 because that's where her savings started at,
Yep.
and then went up by 30 every week.
So when you go over a week and go up 30, is each one of these 10?
They're five.
10, 15, 20, 25, 30. And then 5, 10, 15, 20, 25, 30. And you just kept doing that?
Yeah, but at the same time I was doing the second person every
Oh,
week.
so you were doing both each week so you didn't accidentally do, more weeks than you needed to?
Yeah.
That's very smart. All right, so this one's 75. 10, 15, 20, 25. So it starts here. And it's going up by
25.
25 a week. So 5, 10, 15, 20, 25. So they're getting closer. So that should be right there at 100. And 5, 10, 15, 20, 25. And then and like I said, I'm having trouble seeing that because it's so small. But yeah, you can graph those. And this one is going up by how much? 30 every time?
Yes.
So 5, 10, 15, 20, 25, 30. Is it, where is it? Is it one below or two below?
Two below.
It's two below. Thank you. And then this one's going by 25. So 5, 10, 15, 20, 25. And this one's growing by 30. 5, 10, 15, 20, 25, 30. Wait a minute. I did something wrong there.
You went a bit high on the second person.
I'm sorry.
You went a bit high on the second person.
Oh, okay. So this one should have gone up 1, 2, 3, 4, 5. Should have only gone up here. Thank you. I was like, they shouldn't be getting further apart. And at this point, it's only one below, isn't it? And then when we get to the next one, they're both going through the same point. Yep, that is one of the ways that we can do this. We could use a graph to help us figure out, all right, how are these getting closer and closer together? So the answer is here at 5 weeks. What does this y value tell us for this point? The amount of money that they both have at 5 weeks. All right? So graphing is one way that we could do this. What's another way that you might be able to do this? I can think of two others.
If you make an equation.
Okay, so let's make an equation for both of them and see. So for Latanya, the amount of money that she has is going to be equal to, she started with $50 every week, plus she's getting 30 for every week. And then for George, how much money does he have? What's his equation?
75 plus 25.
Pardon?
Plus 25.
Plus 25
W.
W, yeah. And we want to see where those two are equal. So I'm just going to make them be equal to each other. 50 plus 30W is equal to 75 plus 25W. By the way, if you went straight to this equation, I'm good with that. Right? Instead of writing the two separate ones. So I always move the variables around first. So I'm going to subtract 25W from both sides. And I have 50 plus 5W is equal to 75. Subtract the 50. We have 5W is 25. Then divide by 5. And we get that W is indeed 5. Great. There's one other way that we could do this. What would be another way that you can think of that we might be able to organize this rather than draw it on the graph or to make an equation? Another way we could do it is to use a chart. We could have the number of weeks. We could have Latanya and George. I could make a little chart of how much money they have. So then at week 0, Latanya had $50 and George had 75. She's adding on 30 every week, so that's going to be 80 at week 1, whereas George only adds 25, so he's at 100. After 2 weeks, she's going to add on $30 again, so that's $110. He adds on 25, it's 125. And this is sort of like what you were doing with the graph, right? It's just in a different format. So after 3 weeks, another 30 is $140, and another 25 here is $150. They're getting closer. After 4 weeks, that's $170. And this is plus 25 is $175. After 5 weeks, they're both at $200. So any of those would be fine. Okay, so let's talk about the drawbacks for these. What's the drawback for graphing that? What can you think of with, pardon? It takes a pretty good amount of time, and with this one, since the lines were so small, it was difficult to be super accurate. Yeah. What about for the table?
Takes up space.
Yeah, it takes up space. And the other thing is what if they didn't have the same amount of money until week 30?
That's stressful. I mean, we could skip over if we found how much we made in 1 week, then we could skip over a few.
Well, but if we're doing the table, we got to show every week. But that would be awful, wouldn't it? So in most cases, the equation is the way to go. That's called writing. This is a system of equations. I have two equations, and I want to solve them. And your book calls this the equal values method, meaning you just set those two equations equal to one another and solve. All right, let's go on to page 2. All right, so Gerardo decided to use tables to find the point of intersection of the lines y equals 4x minus 6 and y equals negative 2x plus 3. His tables are shown below. So everybody take a look at the tables for a moment. Is there a common point in the tables that make both the rules true? Pardon? Where? I hear lots of whispering, but not. At 0?
At 1, right? At 1.
Oh, wait a minute. Are you saying there are none? What are you saying? Okay. Sammy, what are you whispering about?
At 2.
At 2, this is 2, but at 2, this one's negative 1.
Oh, so there's
Yeah,
no.
there's none. There's not a single value in the top table that's exactly the same as it is in the bottom table. Now, let's see if we can describe where the point of intersection is going to be. So, when I start at negative 3, the second y value is bigger than the first y value, right? And that stays the same through negative 2 and through negative 1 and at 0 and at 1. But where does it switch? At 2, now the first line has a bigger y value than the second one. Do you see how we switch? Just look at this part. Here, the y value is bigger for the second line than the first line. But here we switch to where the y value for the first line is bigger than it is for the second line. So it's between x equals 1 and x equals 2. All right, everybody graph those two and see if you can find the point of intersection. Graph y equals 4x minus 6 and graph y equals negative 2x plus 3. what was the second one? Negative 2x plus 3. So it looks something like this. So, where do these two intersect? It looks like they intersect at about 1.50, right? Now, I cheated. I used my straight line tool to draw these nice and neat. You're welcome to, if you have to do this, use one of my rulers or one of your own. And that really helps to make it better. I'll tell you that in Algebra 1 in Mr. Bauer's class, if people don't use a ruler to draw lines, he takes points off. He's like, if you're going to draw a line, it better be neat. Okay?
So even for charts and stuff like that?
No, for graphing lines. Not for charts and things like that. I mean, it would be nice, but it doesn't have to be. All right, so let's use our rules to confirm the answer from part C. So we said it was 1.50, right? Paul, can you read me the first equation, the first rule?
Y equals 4x minus 6.
What was it? What x?
4x minus 6.
4x minus 6. Let's see if this really works. I'm going to put 0 in the place of y. I'm going to put 1.5 in the place of x, and I'm going to evaluate. Four times 1.5, well, 1.5 times 2 is 3. So times 4 is 6. So that's true. Christian, please read me the other.
Y equals negative 2x plus 3.
Okay. So let's see. 0 for y. 1.5 for x. Negative 2 times 1.5 is negative 3. Plus 3. Both of those are 0. So we can check it that way. Okay? Any questions about that? Okay.